Good morning, chemistry team. Time for video number 8 in our equilibrium series. It's a new day, a crazy Friday. Hope you're having fun staying at home. At least I'm giving you something to do so you can watch these videos over and over and over and over and get these done, and you can't complain that I talk too fast like you do in lecture. So your chemistry coach is here today. I got my coach shirt on. Let's make it happen. So now, since we've gone through in the last several videos how to manipulate equilibrium equations, look up equilibrium constants, now we can put some math to it. We're going to get into the heart and soul, the meat and potatoes of equilibrium type problems that we're going to run into in this chapter, which for my class is chapter 15, and then 16, and then 17, and then 18, and then 24. And we're just going to do the same stuff over and over. And there's only, as you can see on the table behind me, 3 types of problems we're going to do. So once you learn how to approach each type of problem, it doesn't matter what I give you, whether I give you an acid or a base or a solid. It doesn't matter what I give you. The approach is exactly the same. That's the key to chemistry. It's not really memorizing stuff. It's learning approaches to problems and patterns, right? And doing step-by-step processes, and it doesn't matter what I throw at you. So we're going to start this particular video with the first. I'm going to introduce the 3 types of problems that we're going to get in equilibrium, and then we're going to focus and do an example on the first type. And I break these down into easy, medium, and hard. So let's look at the 3 types of problems. Number 1, what I consider the easy one, right? Basic stuff. We can set up the equilibrium expression, right? Should be very good at that. When you look at your homeworks, probably the first couple pages is just going to take equilibrium equations, setting up the equilibrium expression. Now you got your mathematical formula. Usually you can look up K. Not always. It's not always in a table. So what we can do with that expression is we have a mathematical formula, right? So let's say I have 3 species concentrations in K. That'd be 4 unknowns, or 5 species in it plus K, 6 unknowns. So it just depends how many species you have in there. If I give you all those values except 1, right? So if I give you all the equilibrium concentrations of every species, you could solve for K. If I give you K and all the equilibrium concentrations except for 1 species, you can solve for that 1 unknown species. It's pretty simple math. It's like the PV equals nRT equation. If I give you everything except 1, you just solve for the missing 1. That's why I consider that easy. And it's even easier because you don't have to worry about units, right? If you're solving for a concentration, the units will just be the units of the concentrations you throw in. They're typically molarity, right? So if all the values are provided except 1, you can solve for the other one. So again, 2 different types here within it. Either solve for K, given all the equilibrium concentrations, or solve for an unknown equilibrium concentration if given K and the other values. Now the medium type of problem, you ready? Determine K. Now, the twist on this one, and these are going to be a little bit trickier. There's a big jump in difficulty from here to here. If I give you the initial amounts of the species and the equilibrium amount of one of the species in that equilibrium expression, right? Not in the equilibrium equation. Remember, we don't worry about liquids and solids that condense phase. Only what's in the equilibrium expression are we worried about. So I give you initial amounts of all of them, except 1, and that's the equilibrium amount. We can actually solve for an unknown K value, but there's some mathematical tricks, and that'll be in the next video. So we're going to do 3 videos, type 1, type 2, type 3. And we'll do 1 example, maybe 2 of each. Now the last level, which I consider hard, once you know how to do it, it's not hard anymore. If you practice, it's not hard. Just like sports, just like music, just like learning another language. If you do it over and over, it gets easy. All right. So the last one, if we give you K, and typically you'll look that up in a table or something like that, and only initial amounts. So when this is the only type of problem where you have no information on equilibrium amounts at all. You're like, oh, crud, because I need to put those equilibrium concentrations in the equilibrium expression, right on? So if we know K, if K is given to you, or if you look it up in a table, and initial amounts of all the species, we could calculate the equilibrium amounts of all species, but that's going to require some crazy stuff later, and that'll be in a much later video. So let's pause it. I'm going to write a problem up on the board, and we're going to do the easy type of problem. We'll start off on the skateboard, then we'll get to the bicycle, and then we'll get to the Ferrari after that. So this is your skateboard, this is your bicycle, this is your Ferrari. All right, so let me pause it and erase that board, and we'll do an actual problem. It's going to be easy. All right, gang, time for equilibrium problem type 1. The easy one, remember, Now, again, this is just, once you set up the equilibrium expression, it's just basic mathematics. So let's say we have an equilibrium equation. Doesn't matter what it is, but for this particular one, we got 2 moles of NaCl gas, giving us 2 moles of NO gas and 1 mole of chlorine gas. Okay, in equilibrium, so we're at equilibrium and the concentrations are the same, are constant for all species. We're given Kp, right? Normally Kp values you're not going to look up in a table. Those would be specific ones like Kas, Kbs, KSPs, things like that. So this one's provided for you with 2 significant figures, pretty small, right? Which means this is very, very reactant dominant. Lots of reactants, not too many products in this case. And we're provided some information. We're provided the equilibrium partial pressure of NaCl of 0.44 atmospheres here, right? At equilibrium, that's what we have. And the partial pressure of NO at equilibrium is 0.0015 atmospheres. But we weren't given the partial pressure of chlorine. Remember, a type 1 problem, if I give you the equilibrium amounts of all species, we can calculate K, or if given K and all of them but 1, we can solve for the unknown. So chlorine is our unknown for this problem, right? I want to know what that partial pressure is. And if I plug these values in with atmospheres, the unit will be atmospheres coming out when we do it. So first thing you do, and if you're stuck on a quiz or test and your brain goes, blah, no, I can't think of anything, right? Which has probably happened to most people, happened to me on my PhD oral defense, right? My brain just left my head and I just stood there looking like an idiot. Hey, you can survive these things, right? So if that happens to you on a quiz or a test, just write the equilibrium expression, right? That should be automatic. And if you're stuck there, just go to the next problem. At least you'll get some partial credit. But once you get that down, you've got the first stepping stone. So let's do that. Let's write our equilibrium expression. All right, so at equilibrium, we're going to have Kp, right? In this case, because it's all gases. And they're all gases, so I'm going to put them all in the expression. It's going to be the product over the reactant, so it's going to be the pressure of NO squared, right? Let's do it like this. And then the pressure of Cl2, but that has a 1 in front of it, so that's the first power. And let's divide by the reactants. So we've got the partial pressure of NaCl, and that'll be squared. Easy peasy. You can do that in a couple seconds on an exam or a quiz, right? We know this. We know this. We know this. We'll solve for that, right? Let's isolate our variable, right? That's going to be pretty easy. So the partial pressure of chlorine gas, which is what we're after. I always like people to take their equation and isolate their variable, right? It's a little easier for the reader, whoever's reading it or grading it, to be able to follow, right? So they don't have to do the mathematics. You do it for them. All right, so that's going to be Kp times the partial pressure of NaCl squared. I'm moving up to that side. And then I'm dividing through by the partial pressure of the NO squared, right? So just doing basic algebra there. Remember, algebra is a requirement for this class. And if you're having trouble with that, brush up on it because you got lots of time now because you're stuck in your house. What's Kp? Well, it's 9.2 times 10 to the minus 6. Remember, no units on K values. And then the partial pressure of NaCl was 0.44 atmospheres. You don't even have to put the atmospheres in there. So let's put 0.44. And remember, we got to square it, right? It's squared. Let's divide that by the partial pressure of NO, which is 0.0015. 0.0015. And square it. Two significant figures, two significant figures, two significant figures across the board. So, oh, big surprise, our answer is going to have two significant figures. So I get 0.7916. Vertical dash line, 16. And I'm just going to put atmospheres there because all of the units were atmospheres to start with, right? And then this is closer to 0.79 than to 0.80 because that's less than 5. So I'm not going to round that up. So give me a little arrow. Write your final answer. Box it nice and clearly so whoever's grading it isn't confused. And boom! We have just done the first type of equilibrium problem. Piece of cake, right? You hope your whole test is going to be full of these. Not! All right. So next video, we're going to do a type 2 problem.